What if the story you learned about the first Americans was only part of the truth? What if the land bridge was never the main path? What if ancestors didn't come from where we assumed, but from somewhere far less expected along a coastline erased by time and rising seas? What if ancient DNA hidden inside modern people quietly contradicts everything textbooks once claimed? And what if the ocean, not the land, was the real highway that carried humanity into a new world? For decades, scientists believed the mystery of how humans first arrived in the Americas was already solved. The barren land bridge, the ice-free corridor, the Clovis people. Clean, linear story. Taught and retaught. Yet, as genetic tools sharpened and ancient DNA began to speak with a different voice, the certainties started to fracture. What once looked like a single migration now appears layered, complex, and unsettlingly incomplete. New genomic research has revealed something unexpected, buried deep within mitochondrial DNA, a maternal lineage known as D4H. This genetic signature does not neatly originate from Siberia alone, but traces back toward the northern coastal regions of China. This discovery didn't emerge overnight. It took more than a decade of searching through over 100,000 modern genomes and thousands of ancient remains to reconstruct its path. Through mutation patterns, geographic clustering, and radiocarbon dating, scientists began to see movement not as a single wave, but as at least two distinct migrations unfolding during and after the last ice age. The first migration appears to have occurred at the height of the last glacial maximum, roughly 26,000 years ago, when massive ice sheets locked much of the northern world in frozen silence. Northern China at that time was not a hospitable place, yet human populations were growing, adapting, and pushing against environmental limits. Genetic evidence suggests that some groups moved eastward, following coastlines rather than attempting to cross frozen continental interiors. This was not a desperate gamble, but a calculated adaptation to a world where the sea offered food, predictability, and mobility. The second migration unfolded as the ice began to retreat between 19,000 and 11,000 years ago. During this period, a surprising genetic connection emerges between Native Americans and the indigenous Ainu people of Japan. It suggests that a shared ancestral population once moved along the Pacific Rim, branching in different directions, some reaching Japan, others continuing onward toward the Americas. This aligns with archaeological parallels. Stone tools, fish hooks, and maritime technologies found thousands of kilometers apart, yet strikingly similar in design. This coastal movement supports what is known as the Kelp Highway hypothesis, a theory once considered fringe, now increasingly difficult to ignore. Along the Pacific coastline, vast kelp forests would have formed a continuous ecological corridor rich in fish, shellfish, marine mammals, seabirds, and edible plants. For early humans skilled in basic seafaring, this route offered a stable source of nutrition and a navigable path free from crushing ice sheets. What complicates the story further is timing. The traditional ice-free corridor proposed by the Clovis first model may not have been open or viable. If humans arrived earlier than 13,000 years ago, as mounting evidence suggests, then a coastal route becomes not just plausible, but necessary. Underwater archaeology has begun to support this idea. Human remains and tools discovered in submerged caves off the coasts of Mexico and Florida point toward ancient populations living and dying near the sea, their stories drowned by post-ice age sea level rise. In Japan, discoveries on Okinawa Island deepen the mystery. Fish hooks carved from sea snail shells, dated to more than 23,000 years ago, mirror those found in Indonesia and even California. These artifacts imply not only early fishing, but sophisticated maritime knowledge, far earlier than previously assumed. Charred remains of marine life, seasonal harvesting patterns, and continuous habitation layers suggest that coastal living was not a temporary experiment, but a sustainable long-term strategy. If these populations could survive on remote islands for tens of thousands of years, the idea that they could follow coastlines across continents no longer feels radical. It feels logical. The sea was not a barrier. It was a bridge. This reframes the Americas not as a final destination reached by chance, but as part of a broader Pacific world, connected by water, movement, and shared survival strategies. The ancestors of Native Americans may have been part of a vast coastal network, stretching from East Asia through Beringia and down the Pacific Rim, carrying with them genes, technologies, and cultural knowledge shaped by the ocean. Yet many questions remain unanswered. Where exactly in northern coastal China did this lineage originate? What pressures triggered these movements? Population growth, climate instability, resource competition, or something else entirely? And how many traces of these early coastal migrants lie hidden beneath modern shorelines, waiting to be found? What is becoming clear is that the story of the first Americans is not a single road across frozen land, but a mosaic of journeys, adaptations, and choices made in a world very different from our own. Genetics, archaeology, and geology are converging on a truth that feels both unsettling and exhilarating. Humanity's past is far less tidy than we imagined, and far more interconnected. The ocean remembers, even when the land forgets. And within the DNA of modern people echoes a migration story, written not in footsteps across ice, but in waves, tides, and the quiet persistence of those who follow the edge of the world into the unknown.